Hello, AP Stats Cats. We're going to do a little review of linear regression. I'm guessing that since your AP exam will only have 2 questions, they are not going to have you spend time taking original data, putting it into a calculator, finding the equation that way, and instead you're going to be asked to find the equation based on computer output. You're going to be asked to analyze relationships based on a graph that you're given. That's my guess. Probably also answering questions in context. Surprise, surprise, context in stats? No way. I know. But so I just like to go over a couple of things. First of all, it's important to determine whether you know which is your independent variable and which is your dependent variable. X is always independent, Y is dependent. It's not necessarily that it's a cause and effect kind of relationship. That's always a little dangerous to say, but it's more a case of as one increases, is that going to probably impact the other one? Is the other one likely to follow suit? Or as one increases, could the other one be decreasing? And that helps us go toward the question of direction or association between the variables. But part of that is not only the sign of the association, but also the shape and the strength. So when you take a look at the next part on here, it says, do the variables have a linear relationship? Well, if you ever have to analyze a scatter plot, you really want to address the direction or association, the shape, and the strength. For direction, basically, it's like the sign of the slope. So if you were to go ahead and make a scatter plot, where here's your X and here's your Y, and we're probably focusing on real data that exists, so it's probably just the top first quadrant, you would have a scatter plot maybe that looks something like that. All right, so it's got, as X is getting bigger, Y is getting bigger, so that would be a positive association or positive direction. Likewise, if you have a scatter plot that looks like this, then that's going to have a negative association. And if you were to imagine trying to draw the line that best fit that data, then you would see, oh, it has a negative slope. So the association and the slope, basically the same kind of thing. It's just we're looking only at the sign, not the number. As far as shape, really we're just interested in whether this is linear or not. Yes, it is possible to take nonlinear data, do some transformations, and come up with a regression equation, but that is not something that's covered on the AP exam, or at least it's not supposed to be. So the equation for a regression line is going to be y hat equals a plus bx, where y hat is the predicted value of your function, predicted value of y, whatever that response variable is. A is your y-intercept, and B is the slope. Oops. So direction, shape, the last thing is strength, and your strength is measured by the correlation coefficient R. To be honest, R can be figured out for any relationship that you have, but it really is only meaningful when you have a linear one. The formula is on the packet that you have. You do not need to memorize that. I can't imagine they would ever ask you to find it other than from computer output, and I'm going to show you how to do that in just a minute. But a couple things to remember is that R always sits between -1 and +1. If R has an absolute value of 1, that is the strongest possible relationship. It's probably not going to happen in real life. It's probably only possible if I were to make up an example and it would be perfect. Like it's just not that realistic. But if R is in the 0.9 something, that's really, really strong. R equals 0 basically means that there is no reason to use X to predict Y. There is no correlation whatsoever, so you may as well just throw a dart at the board and make a guess. But the stronger your relationship, the better fit you have, the better job you can do using X to make a prediction of where Y is based on the rest of the pattern, because everything fits so nicely. When you are given a relationship and you know that it's linear, usually there are some typical follow-up questions that you might be asked. For example, can you give us the regression equation? And just as a reminder, regression equation, best fit line, prediction line, all of those mean the same thing. That's the y hat equals a plus bx that we were talking about a minute ago. Probably you will also be asked to describe the slope in context, maybe the y-intercept also, but the slope is usually the biggie. Also, you want to talk about r squared, and that's the one that has that long definition that you may or may not remember. R squared is the percent of the variation in y, which is your response variable, that can be explained by or attributed to linear regression on x. What that basically means is, because of this work you're doing, trying to find the regression equation between x and y, the y value is going to go up and down. There's always variability. We talk about variability in stats all the time. So why does the y value move? Well, r squared tells you the percent of y it moves because of x. And so, for example, if you had an r squared of 0.72, that would be saying 72% of the reason why the y values keep changing in your graph is related to x. The rest of it, the other 28%, is related to other variables. In addition, your residual, that is something that we've talked about a little bit in terms of residual plots. You can find residuals for every single data point, and in order to calculate that, it's the actual y value minus the predicted y value. So your residual, which sometimes people call as a little e for error, I don't think that's super important, but in case you see it, I didn't want you to be surprised. That's really the actual y value minus the y hat. And you can find the y hat by plugging in x into your regression equation, and then take the original y from the data point minus the y hat, and that's your residual. Residuals can be positive or negative. The closer they are to 0, the better fit the point is to the line. And last but not least on this page, make sure to be aware of extrapolation. That really means that your data points are covering a certain range. If all of a sudden you have data, say from x equals 3 to x equals 10, and then you have to make a prediction about what's going to happen when x equals 15, well, you might very honestly say, you know what, I don't know, because my data is only based on x equals 3 to x equals 10. X equals 15 could be a whole different pattern. So watch out whenever you're asked a question like, is it reasonable to make a prediction for this value of x? The answer is, if it's without, if it's within the original set of data, then that's one thing. But if it's beyond that, probably you can't trust the equation. Okay, with that said, make sure that you've got your graphing calculator ready to go, because we're going to do a little bit of calculator practice after we go through the computer output. So please flip the page and I'll see you in a second. The example we're going to look at is investigating the relationship between the number of hours spent studying for a test and the final score on the test. So if you needed to identify which variable is which, probably it makes sense that the longer you spend studying for the test, that could definitely impact what your final score would be. Now, it's not always a guarantee, it's not a perfect fit, but that would make more sense than the other, because you have to do the studying before you take the test, so it couldn't be the other way around. In terms of linear relationship, we don't have the raw data, we don't have a graph, we can't really answer that question, but probably on the AP test, you're going to be asked to look at computer output. So if you take a peek at the box that we have here, this is what you will probably need. Now, I'm going to tell you that the T ratio information and the P information is really nice and all, and you've got it there, and if we had gotten to the very last chapter of the year, we would know what to do with that. As a matter of fact, if you take a look, you'll see that the P values are both very, very small. They're about 0. So that means whatever the test is, we have some significant data. But you don't have to worry about that right now, because we didn't make it that far in the year. So a couple things. First of all, I say here, you know that hours are the units of the independent variable because blank. See if you can figure out why. Did you figure it out? It's because hours is written underneath the word constant. Whatever constant is, that means that that entire row is about the constant. That is the A in your equation. But the next row is all about the slope. And of course, if you think about it, when we write our equation, it's y hat equals a plus bx. So here's the a, here's the b, here's the word that goes along with x. Next, I'd like you to see if you remember where you can find each of the next 4 numbers. given the rest of the numbers that are still available. So take a moment and give it a try. All right, so how did you do? The y-intercept of the regression equation, that is the value of 59.026. Notice again, A is talking about the top row of numbers, B is talking about the bottom. So the y-intercept is the A or the constant in your equation. The slope of the regression equation, on the other hand, that's your B, so that's going to be here, the 6.767. So from this information, even if you didn't have the raw data, you could still make your equation. Y hat equals A, 59.026, plus B, 6.767 times X. All right, next is up to context. Okay, remember that your context, for context of y-intercept, that is the value of y when x is 0. In this case, the y is the test score. When x is 0, so that means for someone who didn't sleep the night before. So got 0 hours of sleep. The context of the slope, which, by the way, if I had to pick one, I'm going to guess that this is what they would ask about. This is always so much more important than the y-intercept. And think about what slope means. It's your change in y over change in x. In this case, that would be change in score over change in hours spent studying. So in context, I would say this. For every additional hour spent studying, a student's score is expected to increase by approximately 6.767 points. So you spend an extra 1 hour, then you get about 6.767 more points. 2 hours, then it's 2 times that. 10 hours, then it's 10 times that. Why? Because it's B times X. That's the change that you're expecting over X hours. As far as standard deviation of the residuals is concerned, that is going to be here, S, 6.135. I don't know that they'll actually ask you about that, but it is on the chart and I wanted to let you know. The smaller the standard deviation, the better, because again, that's saying that there's not so much extra noise, there's not so many differences between the actual data and the expected data. And then last but not least, our coefficient of determination, R squared. We've got that right here, R squared equals 74.7%. Yes, it is true that there's the other one, the R squared 80J, but you don't need that one either. So what I would do for the R squared is turn that into a decimal instead of a percent, take the square root, make sure to check the sign of the slope because the sign of the slope will be equal to the sign of the R. In this case, ours that was a positive slope. So that means we're going to have a positive R. But watch out, because if your number right here in the turquoise, 6.767, if that had been negative, that means you would have to have a negative value of R to match the slope. Your context, again, is going to be based on what we said on the other page. So see if you can figure it out and then come back and see if our answers match. All right, please check your answer. It should be that since R squared is 74.7%, that 74.7% of the variation in test scores, because that's the Y value, can be explained by the amount of time spent studying. So the other roughly 25% of the score could be based on all sorts of other things. There could be lots of different confounding variables out there. It could be socioeconomic status. It could be, what did you have for breakfast? It could be, do you like the professor? It could be, ooh, was there a really cute person sitting next to you and you were totally distracted while taking the test? I mean, all sorts of different things. So at least we can say, based on the data that we're researching, about 75% of it has a connection. All right, just to finish up here, as a reminder, the equation for the regression line is y hat equals a plus bx. So in this case, based on the numbers that we have, our equation is, all right, you see the equation for y hat as well as for r there on the bottom of the page. I'm running out of time. Surprise, surprise. Hopefully this makes sense to you. If you do have further questions, please join me again at either 11 a.m. or 4 p.m. I will have Google Meets ready, and you can find the links for that on Google Classroom. There is a practice FRQ also that is attached to this, so go ahead and give it a try, and the answers are posted on Google Classroom. Have an awesome weekend, everybody. Take care. We'll have to wait for the calculator stuff until next time. Bye. Happy weekend.